So this is sample problem 1 for the topic steady electric currents. So we are given the expression for electric density J, and we are tasked to determine J at a specific point 3, 30 degrees, and 2. We are also tasked to determine the total current passing through the circular band denoted by rho, or bounded by rho is equal to 3, phi from 0 to 2 pi, and z from 2 to 2.8. So for the circular band, this is the illustration. So we get the total current passing through this area, surface area, which is the lateral area of the cylinder, and from z is equal to 2 to 2.8, and having a fixed radius of 3, and from phi from 0 to 2 pi. So if you have to determine the J for a specific point, so at point 3, 30 degrees, and 2, so we can just substitute the values. So that would be J is equal to 10 times 3 squared times 2 a rho minus 4 times 3 cosine of 30 degrees quantity squared a phi milliampere per meter squared. So that would give us an answer of 180 a rho minus 9 a phi milliampere per meter squared. So if we're going to solve for the total current through this circular band, so what we can do is we can get the current through that surface area by using the equation, the integral of J dot ds, where J is the current density and ds is the surface. See, we already have the expression for J, so that would be 10 rho squared z a rho minus 4 rho cosine squared phi a phi milliampere per meter dot ds. So what will be the ds for this region, or for this example? So since rho is constant and this is the region that we have to consider, therefore the differential surface would be rho d phi and dz with a unit vector a rho. So we can compute for the total current. So we will first evaluate the dot product. So the a rho terms will only remain, and this will be cancelled out since we're dealing with the dot product. So we are left with 10 rho cubed z d phi or d phi dz, and we have to evaluate the integral. We have to separate the integral. So this will be double integration. So z, the integral of z dz, and the integral of d phi. So for z, from 2 to 2.8, and from phi from 0 to 2 pi, as stated in the problem. And rho is equivalent to 3. So since rho is equivalent to 3, we will just substitute that. So let's remember that we have a 1 times 10 to the negative 3, because the J is in milliampere per meters. So we will just evaluate. So rho is equal to 3, so that's 3 cubed. So if I'm going to integrate z, that would be z squared over 2 from 2 to 2.8, and phi from 0 to 2 pi multiplied by 10 to the negative 3. So if we evaluate this entire integral, we are going to get total current of 3.257 amperes.